Hello, I'm Rainy Day, and welcome to day 30, the final day of Sudoku September. And for this, I thought I'd talk through a puzzle I made a while ago called Dittoes. So it's going to be a bit of a different video, I guess. More going to be explanatory than trying to rush to solve. So, Dittoes works like this. So on the grid, you have got 14 cages, each of which add up to 27. These would be normally highlighted if I could have put it in to the converter, but I can find a way to do that, so I'm just leaving these as cages here. They are not proper like killer cages though. Digits can repeat in these cages, as long as they follow normal Sudoku rules. Now, 3 boxes in the grid, for example, in theory, like those 3 for example, are identical, and another 2 are also identical, and the remaining 4 are all unique. So, with these constraints, how exactly would you go around solving these? Well, to start with, you've actually got one digit you can get pretty easily via killer logic. This cage is 27, and this cage is 27. So combined, they are 54. These, as a box, add up to 45. So this one is a 9. And then it feels like it's a bit stuck, right? So we've got to do at least how I solve it from this point, because I did do this using Google Sheets originally when trying to figure out how to solve it, which is a bit annoying, but this is a bit more convenient, I think. So from this point, we are going to have to figure out what the triple is as the next easiest thing. So take, for example, any box, like box 2. Because of how Sudoku rules work, where numbers can't repeat in a row or column, we have already eliminated 4 of the boxes that it could be. So for each box here, there's only 2 options. So it's going to be this one and that one. There's going to be that one and that one. So let's sort of go through each possibility. I will highlight them just based on corners, I guess. So for example, for 1, which we'll highlight in red, it can match with either 5, 9, or it can highlight with 6, 8. For 2, it can highlight with 6, 7, or it can highlight with 4, 9. And then finally, for box 3, I shouldn't actually do these in yellow, I should do them in so 3 can go to 4, 8, or it can go to 5 and 7. So immediately we would have a problem. 1, 5, 9 does not work because this 3 would have to go here, which is already taken up by the 6. So that possibility does not work. Unfortunately, I don't think there's any other ones where we can use this logic mainly. The ones which do have repeat positions are in the same row, so not helpful. The next thing we can use, which helps a bit, is cages of 27 that only have 4 digits. And there are only 2 in this puzzle. But the options for this are 3, 7, 8, 9, 4, 6, 8, 9, 5, 6, 7, 9 are the only options. But the point is, it's got to have a 9 in. Because the max without it, 5, 6, 7, 8, is only 26. Now, it would be worth noting whether this 9 here breaks either of these. It doesn't break it if it was in green, because it can go here. But if it was going via orange, 9 would have to go here, which would break this cage. So we know that ranges do not work. It's been a bit of a while since I actually looked at this, so what do we want to do next? I think next we are figuring out those. We can do some. Okay, so this is where we're doing a bit more interesting logic stuff. So within this box, we have got 30 of the 15 already known. Right? So those add up to 15. And it is. I'm trying to remember what it is. Is it about. It might be actually, that's 18. And that's 27. So those two are going to be 9 less than those two. I think is how that works. Oh no, this is it. So suppose yellow was this one, right? And that's a 2. Now, we would have a situation where those are 25 and those are 15, which will make this 10 less than that. So what options do we have for this? Well, firstly, just by the options, it can't be 3 because of row. Now, it cannot be 9 because that has to be 19, and that can't be done with only 2, and that's the same thing. If it was 7, this has to be specifically 9/8 as a pair. And that is going to be 9/8. And that is going to be, well, mine would have to go there specifically. So that would be 8, that would be 9, 8, 9, 8, 9. That would be 7. I'm pretty sure this is the hardest one to disprove. I think it is quite long-winded, so do permit this to take a bit to disprove. So this needs to add up to 8, right? Actually, maybe it might be something to do with it actually, but I guess that adds up to 18, so they add up to 9. I mean, they can't be 5, 4. But let's not start this, I guess. They are 8, so it can't be 2, 6, and it can't be 3, 5. Actually, no, it could be 2, 6, right? Yeah, it can be 2, 6. Oh no, it can't be 1, 7. It would have to be 2, 6, that is. Puts 2 in one of those. 9. Okay. So 8 can only go in one place within here. And 2 would have to go in there. 9 would have to go in one of those. Now, it is worth noting we do not yet know what the double is. But suppose we do, like, highlight the entirety of those boxes in yellow. We've got a few options. One can match with 6, or it can match with 9. 2 can match with 6, 7, or 9. 5 can match with 7 or 9. That I don't think is needed, though, from what I remember doing this. I'm pretty sure that this is the hardest one to disprove from what I remember. 8 is in one of those. 9 would have to be in one of 2 there. There's kind of a 4 in. Now, again, yeah, 5, 6, 7, 9 could work. Oh yeah, there's an 8 in that box, so it would have to be 5, 6, 7. I would put a 7 in here. Oh, and remember that actually this is mirrored as well, so that's a 2. And that would be, oh, this is it, yeah. 5, 6, 7 in there, but if there was 5, 6, 7 in here, there's 7 in there disproves it. So, can't be 7. So we've disproved those as being, can't be 7. Okay. What about 6? 6 will make this 7, 9, which makes that 7, 9, that's 7, 9. Okay, so let's try out 6. Which there is actually only one possibility. Anything that does require a 9 actually would have to go in here. And yeah, we've immediately got a problem. 7 in there clashes. The different 7 we've got. Can't be 6. What about 5? So, this would have to be 15, but it can't be 6, 9, so it is 7, 8, which is the same there. So that would be 8, and that would be 7, so it doesn't clash. So where does the 9 go? 9 can't go here. 9 can't go there because it can't go there. So 9 would have to go in the center there. Which puts 2, 9 there, and then 9's on the outside. And it is actually worth noting, for anything where this isn't a 9, 9 is forced there, and it would force it on the outside, which it breaks. So 6 doesn't work. 5 doesn't work. 4 makes this add up to 14, and it can't be either by row. 12 can't be 3, 9, which would put a 9 there, put it on the outside, it doesn't work. Final one is 11, so it would be, can't be 2, 9, so 9 is forced on there, which would put a 9 outside. So there we are. We have just proved that cannot be yellow. Okay, I'll split there.